This is the first lesson in the circulatory system. It's going to cover blood vessels as well as the functions of the circulatory system. All of the circulatory information is covered in Chapter 10 of the BC Biology 12 textbook, and there are a number of online anatomy models that might be helpful for you to look at as we look at some of the structures to help you visualize these things in 3 dimensions. The circulatory system is a network. It includes the pump, which is the heart, as well as the blood vessels, the tubes that blood flows through. And the function of the circulatory system is really one of transport. It moves oxygen around the body, delivers it to the tissues and muscles, and then returns the waste products and carbon dioxide to be carried out of the body through exhalation. And it also helps to transport hormones around the body. Again, there are a number of videos embedded in this presentation. Please feel free to go back and watch them linked in the slides for you. All right, the blood vessels. The goals for this are to be able to analyze relationships within the vessels of the circulatory system. There are a number of blood vessels you'll need to know, and they're listed here. You should be able to tell us on a diagram where they are and what the function is. So where is the blood coming from? Where is the blood going to? Subclavian arteries and veins, jugular veins, carotid arteries, mesenteric arteries, anterior and posterior vena cava, the pulmonary veins and arteries, hepatic vein, hepatic portal vein, renal arteries and veins, iliac arteries and veins, the coronary arteries and veins, and the aorta. You should also be able to describe and differentiate among the 5 different types of blood vessels with their characteristics of their structure, thickness, whether or not they have valves, and the direction of blood flow. The 3 types, or 5 types, depending on how you count them, of blood vessels are the arteries and arterioles, the capillaries, and the veins and venules. Now, blood flows away from the heart with the arteries. Transfer of materials happens in the capillaries, and then blood returns back into the heart through the venules and veins. You'll often see this depicted as oxygenated blood in red in the arteries and deoxygenated blood in blue in the veins. Your blood is never blue. It may look a little bit blue if you look through your skin, but humans' blood is actually always red. Oxygenated blood certainly is a bit of a brighter red, and deoxygenated blood is a bit of a darker red, but blood in humans is always red. Crabs, however, do have blue blood. You've got this diagram in your notes, and as we go through the different structures, please add some labels to it. You'll notice we're going to stick with the red for arteries and blue for veins. Remember, you don't have blue blood, but we will keep coloring veins in blue just for simplicity and clarity. First up are the arteries and the arterioles. The function of the arteries is to carry blood away from the heart and towards the capillaries. A for arteries, A for away. The structure of the artery is that there are 3 layers of tissues. The interior space where the blood flows is called the lumen, and lining the lumen is the endothelium. Endo just means inside, and that is a stretchy, squamous-celled epithelial layer that hopefully is smooth and allows for easy and unencumbered blood flow. The middle layer is a thick layer of cardiac muscle that is able to contract to regulate blood flow and blood pressure. And the outer layer of the arteries and arterioles is a very fibrous and robust layer of connective tissue containing collagen fibers that is able to withstand the high pressures that the arteries are subjected to. If you could feel an artery and a vein, you would notice that the artery has a much tougher and more rigid feel to it. The veins feel a little bit floppier and soft. The largest artery in the body is the aorta, and an average healthy adult has an aorta diameter about 2.5 centimeters or 25 millimeters. So if you measure across here, it's about as big as the average garden hose. As the arteries narrow and branch out, they form smaller arterioles down to about 0.5 millimeter in diameter. And what's maintaining the blood flow throughout all of these arteries and arterioles is the pumping heart muscle. The muscles in the arteries themselves help to affect the blood pressure. A dilated vessel is larger, and therefore the blood is subjected to a lower blood pressure. You can see here the aorta has an ascending region as it comes up out of the heart. This little 3 bumps here is the aortic valve. This ascending thoracic aorta arches over here, and these blood vessels branch up to the head, neck, and arms, and then curves down to the descending thoracic. And now thoracic is the cavity that is within your rib cage. So the lower border of that is the diaphragm and extends up to your shoulders. So that's your thoracic cavity. And then below the diaphragm is the abdominal cavity, and the aorta passes right through the diaphragm and continues down into the abdominal cavity, where it branches out to the mesenteric arteries, the hepatic arteries, and then finally branching into these 2 final iliac arteries, which serve the lower extremities. Here you can see a number of arteries labeled. The ones you'll need to know: carotid, subclavian, the aorta, the coronary arteries, which are the arteries that actually serve the heart muscle itself. And then down here, the iliac arteries, the mesenteric arteries, and I think that's all from this diagram. Again, that list is on the first slide here and also in your notes. Some common disorders that are associated with arteries are arteriosclerosis and atherosclerosis. Both of these reduce blood flow and are common with old age. Arteriosclerosis is a hardening of the arteries, often associated with smoking, high cholesterol, or high blood pressure. The walls of the arteries become less stretchy and elastic, and that can lead to issues with blood pressure. Atherosclerosis is where fatty deposits or plaques start to build up within the arteries. It also reduces the blood flow, and that can cause strokes or heart attack if those blocked vessels are in the brain or in the heart. Now, an aneurysm is almost the opposite. An aneurysm is where the walls of the artery become weakened, and instead of that rigid outer layer holding all that pressure in, they start to bulge or stretch. Too much stretching can lead to a rupture, and again, that can be quite fatal if that happens in the brain or in the heart. So here you can see a picture of an atherosclerosis, some plaque building up here, which is going to impede the flow of blood through this blood vessel. If you've heard of someone having a coronary bypass, likely this was the cause, that one of the coronary arteries, or more than one, became blocked, and they actually had to build another route, a bypass, to get around the blockage and continue to supply the heart muscle with healthy oxygenated blood. This here would be an example of an aortic aneurysm. Here we have the normal 2.5 centimeter heart with the aorta, and here we have an enlarged aorta, an aortic aneurysm. The reason this is interesting to me is I actually had this condition. So this x-ray here is my chest, taken in 2014. And you can see this little metal frame here is actually an artificial graft valve. And I have also a section of artificial grafted aorta. So my enlarged aorta was replaced with a little Teflon graft and this new aortic valve. This here is the front of my chest, my sternum, and you can see all these little twist ties holding my rib cage together. Into the capillaries. So after blood has traveled away from the heart in the arteries and arterioles, the blood vessels get narrower and narrower until eventually they get so narrow that only a single blood vessel can pass through at a time. These are the capillaries, and the capillaries are where all of that blood to tissue exchange of gases, nutrients, and wastes is going to occur. Although the capillaries themselves are very, very small, there are so many of them in the body that in total they would cover a surface area of about 6,000 square meters. You can see here, shown in red, this oxygen-rich arterial blood flowing into the capillary. As the blood flow slows down and the capillary walls are in close contact with the blood cells, the oxygen starts to diffuse out of those blood cells, and carbon dioxide and other wastes diffuse into those blood cells and then are returned to the heart through the veins. Now, capillary bed is just a cluster of different capillary vessels all together. They're very common in muscles, in organs, and also underneath your skin. Capillary beds have the ability to regulate the flow of blood through them, or to bypass through this thoroughfare channel the capillary bed altogether if necessary. There are sphincters at the arterial end of the capillary bed that can minimize or limit or completely stop blood flow into the capillaries. Instead, blood would flow through this meta-arterial or this thoroughfare channel and bypass the capillary bed. This is common when a person becomes overheated and needs to cool down quickly. You might be familiar with what overheated looks like. You could see a flushed red face, and that's because the capillary sphincters are relaxed, allowing lots of blood to come to the surface close to the skin. That allows blood to cool off. The opposite is true when a person feels very cold. Your body is going to try and keep all of that warm blood close to the core of the body and limit how much blood is exposed to the elements. And so if you've been very cold and your lips or your fingers started to turn white or blue, that was because these sphincters were constricting and limiting blood flow. So that's called vasoconstriction when they close up, or vasodilation when they open. Again, there's a little video here if you'd like to see it in action. And the veins. So the veins have an opposite function of the arteries. Their job is to return blood back to the heart from the capillary beds. They have the same three layers as the arteries do, an outer connective tissue layer and muscle layer in the middle, and then an endothelium lining, but they are much, much thinner. The lumen, the internal cavity of a vein, is much larger, and because of those two factors, the veins experience a much lower blood pressure. If you were doing a dissection and were to feel the veins, they're quite floppy and soft compared to the rigid and stiff arteries. Blood flow in the veins is maintained by the skeletal muscle contraction. So the muscles that veins flow through help to squeeze and push the blood back up towards the heart. To minimize backflow and blood pooling, veins have valves. So V for veins, V for valves. They are the only blood vessels that contain valves. A healthy vein valve is going to stop blood from flowing backwards and pooling. An unhealthy or diseased vein valve may not function properly, and you can see here that blood is not pushed upwards, but actually is able to flow backwards and between every muscle contraction. The largest veins in the body are the vena cava. There's actually a superior and inferior, or anterior and posterior, depending on if you stand up on two legs or walk on four legs. But superior is the one that comes out of the top of the heart, also sometimes called the anterior. And the inferior or posterior comes down from the bottom of the heart. And they are almost as large as the aorta, although not quite. And they serve to return blood back to the heart as they collect blood from the narrower venules, which can converge and drain into the veins. The thinner walls of the veins means that they can actually hold more blood, and so at any given time, about 70% of the blood in your body is contained within the venous system. Some disorders associated with the veins, varicose veins, which is where those valves fail to prevent backflow, and so blood pools and collects and causes the veins to bulge. Often it can be a little bit painful, although it's not particularly dangerous. A deep vein thrombosis can be dangerous, and so this is where blood flow is reduced or slowed, also sometimes some backflow, and that can cause clots to form in those veins, and clots can then break away and travel to other parts of the body, which can be quite dangerous or even fatal. So if you've had someone talk about needing to get up and stretch their legs, or if you've ever had a long flight where they've given you instructions about how to do some stretches or wiggling of your toes, likely that was to help prevent deep vein thrombosis, which is common when a person is sitting for a very long period of time. Again, little videos for you to take a peek at. And some of the veins that you'll need to know. We've got our jugular, serving the neck and head, the vena cava, superior and inferior, the hepatic veins and hepatic portal vein, which are associated with the liver, the mesenteric vein, which serves the digestive system, iliac veins, which serve the lower extremities, and subclavian vein, which serves the upper extremities.